Good morning, students. Myself, Parvi Suksare, lecturer as a MTD department. Now, here in this video, we will see a revision classes for some MTD students. First unit, Introduction to Machine Tool Design. Here, first question: explain machine tool design. Here, the design of new machine tool can be justified in individual cases on the basis of productivity and accuracy, lower metal requirements of machine tool, etc. In general, all these ideas which accounts for the cost of manufacture of machine tool and its operation can be unified into a general index of economic effectiveness. A machine tool is a machine which converts raw materials into the required shape and size, dimensions, and accuracy. The unwanted materials are removed from the raw materials in the form of chips. That is a machine tool design. Next question: list the general requirements of machine tool design. Here, the list are: first one, high productivity; second one, ability to provide the required accuracy, shape, and size, and also necessary surface finish. Next one, simplicity of design. Next one, safety and convenience of control. Next one, good appearance. Next one, low cost of manufacturing and operations. That is, list the general requirements of machine tool design. Here, next question: explain with neat sketch shank design of single point cutting tool. In this diagram, three cutting forces are Px, Py, and Pz, breadth and height of the single point cutting tool. The shank of single point cutting tool may be rectangular or square or half round, most common use. Square section withstand deformation due to compound bending stress. It is used for boring and threading. The half round section tool is used for internal thread cutting and boring. The tool is defined from the point of view of strength and rigidity. Assuming that the tool is loaded as a cantilever beam, the tool forces acting at the cutting edge is shown in figure. All the forces except the force Pz is neglected for design. That is single point cutting tool. And here the derivation: actual bending moment produced by the force Pz is Mb is equal to Pz into L, and the permissible bending moment induced in the tool material is given by Mb is Mb dash, that is permissible bending moment, stress into Z, where permissible bending stress sigma and Z is section modulus. Z is equal to Bs square by 6, the rectangular cross section. Z is equal to pi dq by 32 for circular cross section, and Z is equal to bq by 6 for the square cross section. In order to make design shape, Mb dash is equal to greater or equal to Mb. Here stress into Z is equal to Pz into L. Here Pz is substitute stress into Z divided by L. Pz is equal to stress sigma into Bh square by 6, that is rectangular cross section, divided by L. Pz is equal to stress into pi dq by 32 divided by L is circular cross section. Pz is equal to stress into BQ by 6 divided by L for square cross section. Here the substitution Pz stress into Z is equal to Pz into L. BH square by 6 is a rectangular is equal to Pz into L divided by stress. That is substitution. B is equal to square root of 19.2 into Pz divided by 2.56 into stress. That is rectangular cross section. The deflection of cutting tool can be obtained from the following equation. Deflection delta is equal to Pz into L cube divided by 3 into EI. E for Young's modulus of the tool material. I is a moment of inertia. I is equal to BH cube by 12 rectangular cross section. I is equal to B raised to 4 by 12 square cross section. I is equal to pi D raised to 4 divided by 64 circular cross section. The value of deflection must be within permissible limit, which is around 0.005 to 0.012 mm. First problem. A 10-degree back rake angle of single point cutting tool is used for machining on a lathe at speed of 60 meter per minute. The dia of the workpiece is 100 mm. Find the cross section of a rectangular tool shank. Assume a rectangular shank with height to width ratio is 1.6 b and tool overhanging is 3.2 times the width. The recorded value of the cutting force is 2500 Newton. Assume Young's modulus E is equal to 2.1 into 10 raised to 5 and shear stress is 75 Newton per mm square. Here first problem is how to solve this problem. Here given data is V, speed is 60 meter per minute, diameter is 100 mm, height is 1.6 times of width, L is 3.2 times of width. Young's modulus 2.1 into 10 raised to 5 Newton per mm square. Stress Pz is equal to 2500 Newton and force is 2500 Newton. Stress is 75 Newton per mm square. You find out breadth, height, deflection, natural frequency and cutting frequency. Here the natural frequency formula is 0.625 divided by square root of delta. Cutting frequency is 1000 into V divided by pi into D into 60. Here breadth B is equal to formula is 19.2 into Pz divided by 2.56 into stress. That is substitution 19.5 into force is 2500 divided by 2.56 into stress is 75. That is the value is B is equal to 15.81 mm. That is the height is 1.6 times of breadth, 1.6 into 15, that is 25.29 mm. Length is 3.2, breadth 3.2 into 15.81 is equal to 15.59. Next deflection. Deflection delta is equal to Pz into L cube divided by 3 into EI. Deflection delta is equal to 2500 into length is 50.59 whole cube divided by 3 into Young's modulus is 2.1 into 10 raised to 5 into 21310.6 is a moment of inertia I. That is I. How to find out I? I is equal to BH cube by 12 because this problem is rectangular. That's why breadth is 15.81 into height is 25.29 whole cube divided by 12. So I is 21310.6. That is the substitution. Deflection delta is equal to 0.024 mm. And next one, to find the natural frequency, Fn is equal to 0.625 divided by square root of delta. 0.625 divided by square root of 0.024. Deflection is 0.024. That is the answer is 4.03 cycle per second. Cutting frequency Fc is equal to 1000 into V divided by pi D into 60. 1000 into V is speed 60 divided by pi, diameter is 100 and 60. That is 3.18 cycle per second. That's why natural frequency is greater than cutting frequency. So the design is safe. This problem. Next, second problem. A single point cutting tool is used for machining on a lathe at a speed of 70 meters per minute. The dia of the workpiece is 130 mm. Find the cross section of a circular tool shank. Assume the overhanging length of tool is 2 times the dia of the tool. The recommended value of the cutting force is 2500 Newton per mm square. Assume E is equal to 0.2 into 10 raised to 5 Newton per mm square. Permissible stress is 80 Newton per mm square. Find the natural frequency as well as cutting frequency. Okay, you find out given data. Speed is 70 meter per minute, diameter is 130 mm, length is twice of diameter, force is 2500 Newton per mm square, stress is 80 Newton per mm square. Solution. Find the diameter of the cutting tool. Here the formula is permissible bending moment is equal to bending moment. M dash B is equal to MB. Z is equal to Pz into L divided by sigma. Z is 5dq by 32 is equal to Pz is 2 into 2d divided by stress. D square is equal to 64 into Pz divided by pi into stress. This is D is equal to square root of 64 into Pz divided by pi into stress is 80. So the result diameter D is equal to 25.23 mm. Length L is equal to twice of diameter, that is 2 into 25.23, that is 50.46 mm. Next, finding the deflection delta. Delta is equal to Pz into L cube divided by 3 into EI. Deflection delta is equal to 2500 into length is 50.46 whole cube divided by 3 into Young's modulus is 2.2 into 10 raised to 5 into I is 19890.18. I means what? Moment of inertia 5 d raised to 4 by 64. Diameter is 25.23. Whole raised to 4 is I is 19890.18. That is deflection delta is equal to 0.024 mm. You finding natural frequency. Fn is equal to 0.625 divided by square root of delta, that is 0.024. The answer is 4.03 cycle per revolution. Natural frequency. Cutting frequency is 1000 into V 70 divided by pi. Diameter is 130 into 60, that is 2.8 cycle per revolution. So natural frequency is greater than cutting frequency. So the design is safe. This is the complete of unit. Thank you.